Hi, in a previous video we've spoken about proof of induction, but today we're going to talk about some application and how to use this basically proof of induction to solve a couple of problems. For today's example, we got an example of problem in here. We need to use the proof of induction to prove that it's true. The problem says, this exercise says, prove that this formula here, which is 27 times 23 power n plus 17 times 10 power 2 times n plus 22 n is divisible by 11 for all n belongs to n. We know this group in here, n is group of natural numbers, which is starts by 1, 2, 3, 4, 5, etc., until plus infinity. So, as we spoke in the last video, we got 4 steps to prove this problem. We have to prove it in 4 steps. First step is, before we start, we have to give this equation here a name, which is we're gonna name it f n equals, basically just give it a f for function of n, or in mathematics we said f for n or fn equals, basically you have to write the same formula again, 27 times 23 power n plus 17 times 10 power 2n plus 22n. This is our problems. Basically, we define our problem, what is, and we go there to make it clear. We have to give it a name. Now, first thing is, we have to prove that it's true. Prove that basically the statement fn is divisible or is true for. Here we ask for, we go back to the foundations, the base, we said n belongs to n. N is basically a group of natural numbers, the smallest numbers, or we start this group by number 1, basically for n equals 1. What we have to do in here, we have to replace all n in this function in here by number 1. Basically, if we said f1, we have to write replace every single symbol n by 1, which is give us 27 times 23 power 1 remains 23 plus 17 times 10 power 2 times 1, which is 2, plus 22 times 1 still 22. And then all you have to do in here, just simplify these numbers, which is gonna be 2343. After that, if you simplify it again, to prove that it's divisible by 11, basically you have to prove it equals 11 times another number. Basically this number is divisible by 11, or you can divide it by 11. Basically it's gonna be 11 times 20, 213, sorry. 213. If f1 equals 11 times 213, that means f1 is divisible by 11, then this is f1 is, or the statement but for n equals 1 is true. We prove that this problem in here is true for all n equals 1. Basically, the basic, as we spoke in the previous video, the first rule is correct, is solid, which is n equals 1. Now, we go to number 2, step number 2. This is step number 1 over. We take it in, booleans. Now, step number 2. Step number 2 is that simple and that easy. What we have to do, we assume that f k for, sorry, fn, not fk, fn is true for all k. K belongs to n. It's basically f k equals. What we have to do in here, we assume that this equation here is correct, but not for n in here, it's for k. Basically, k is a different belongs to n. But basically, to keep it simple, n and k are just symbols in here. Fk equals, how can we write Fk? Fk is the same function as Fn, but basically instead of writing n, we're gonna write k in here. Basically, Fk equals 27 times 23 power k plus 17 times 10 power 2 k in here plus 22 k. We assume that Fk is correct for k belongs to n. We assume that this problem is correct, but now we can't just stop in here. Now this is where the real problem starts, the real work starts. Now what we have to do, we have to prove that f k plus 1, the next step of k, which is k plus 1 is true or is divisible by 11. Basically divisible by 11, all we said is true, which is completely fine. Now what is it? F k plus 1. F k plus 1 equals, basically here, instead of writing Fn, we're going to write Fk plus 1, which is 27 times 23 k plus 1 plus 17 times 10 power 2. Be careful here, have to be careful, k plus 1 between brackets in here. 2 times k plus 1, it's not 2k plus 1, it's 2 times k plus 1 plus in here 22k plus 1. We have to be really careful and replace every single symbol n or k by k plus 1 in here. When you write it, be careful with that. We have to be really slow and concentrate, because there's a lot of symbols in here and it's going to be maybe sometimes difficult or make a mistake when you distribute your number in here. Let's basically simple 2 times k plus 1. A lot of people made mistake, they write 2k plus 1, which is 2k plus 2 actually. All right, now I'm gonna clear my board in here to give myself more space, and then we keep going with our function. And basically we prove number 1, first step, and we've got some second step done as well. Now we're gonna go toward the third step in here. Cool. Okay, for the third step, basically I'm gonna write again f k plus 1 equals 27 times 23 k plus 1 plus 17 times 2 k plus 1 plus 22 k plus 1. All I have to do in here, I'm gonna simplify this function in here, fk plus 1, and write it, it's this way of fn or fk. If you remember what we spoken just before, fk in step number 3, because we said step number 2, because we said fk is correct, which is now we have to prove it. We have to write it in a way that it got in it, fk, then we can prove it that is divisible by 11. All we have to do first, we don't have to worry about anything, we have to simplify this writing. What we can go in here equals 27 here times 23 power k plus 1, we can write it this way, 23 power k times 23. This is 23 times power k plus 1 plus 17 10 power 2 times k plus 1, we can write it this way, 10 power 2k times 10 power 2, or 10 square, plus in here is that simple, 22k times k, which is 22k, plus 22 times 1, which is 22. Now from here, this times, and then times. All we have to do in here, simplify again, make it simple. Basically in here, what we can write, 27 times 22 power k, we keep it as it is, but 23 here, we have to make it looks like divisible by 11. Basically 23, we can write it this way: 22 plus 1. This is 23 times 27 times 23 power k plus 17, we keep it the same, 17 times 10 power 2k. This one and this one kept it the same in here. Third number here, which is 10 squared, which is 100, we can write it this way: times 99 plus 1. This is 100 plus 22 times k plus 22. Okay, now all we have to do, simplify again, as simple as this. How can we write it now? We can write it this way in here: 22 times this number here, which is 27, times 27 times 23 power k, plus 1 times this number, which is 127 times 23 power k, plus here 17 times 10 power 2k times 1, keep it the same, 17 times 10 power 2k, this times 1, plus 17 times 10 power 2k times 99. Yes, clear so far? Simple and easy. Plus 22 times k plus 22. Now what we have to do, we have to simplify it again. Equals. All we need in here, we need just to write it back as fk, fek, fk, f4k, as we said for in question number, when we said number 2, we assume the equation is correct. Basically, just to remind you, fk, just to remind you here, fk, we should also write it, basically it's written in your book, because you just clear the book away, clear the board here. It's 27 times 23 power k plus 17 times 10 power 2k plus 22k. We said this is correct. Basically, this is divisible by 11. We assume that this is divisible by 11. I'll just write it down in the bottom here as a reminder, because we're gonna get back to it now. What we have to do, we have to write this formula here, get this part, this formula fk, out from this writing in here. What we need, we got 27 to 123 power k. Do we have this in here? Yes, here it is. We write it here, basically 27 times 23 power k. We're done with this. And now, do we have 17 times 10 power 2k? Let's see, 17 times power 2k. Here we go. I'll just try to make it simple for you here. 17 times 10 power 2k. Correct. We got it. We're done with this. We're done with this. 22k. Here we go. This is it. Plus 22 times k. Then we're done with this. What we've got, we have to write 1, this one, 2, and then 3. Then 3. Basically, numbers just there to keep going and writing the whole formula. 27 times 23 power k. We're done with this. Plus 17 times 10 power 2k times 99. We're done with this. And then we've got 22. Cool. Brilliant. Now, we've got this, the whole formula here, or this function fk, here is exactly the same where it is here. We can replace all this formula here by fk equal fk. This is fk now. Plus, now we have to write the same what we've got left from our function, which is 22 times 27 times 23 power k plus 99 times 17 times 10 power 2k plus 22. Okay, this is fk plus 1. Remember, this is what we are writing down, fk plus 1. And what we have been asking for, or what we want to do, we have to prove that fk plus 1 is divisible by 11. If you want to prove that fk plus 1 is divisible by 11, we have to prove that this function here is divisible by 11. To prove that this function is divisible by 11, we have to prove that every single symbol here, basically 1, 2, 3, and 4, we have to prove this one, number 1, 2, 3, and 4 are divisible by 11. We said in number 2, we assumed that fk, which is this formula here, is divisible by 11. That means number 1 is sorted, is divisible by 11. Now go to number 2. Number 2, to prove that 22 times 27 times 23 power k is divisible by 11, that means we have to prove one of these numbers, just one of them, number 2 here, just one of them is divisible by 11. That means the whole of it is divisible by 11, which is that simple. Is 22 divisible by 11? Yes, that means 22 is divisible. That means whatever we write times 22 is still divisible by 11. This is that simple and basic maths for you for A level. 22 divisible by 11, that means the whole number here is divisible by 11. Now we go to number 3. Number 3 here, we got 99 times 17 times 10 power 2k. If it's divisible by 11, this is what we have to prove, or we have to say, because it's straightforward here. Which number here is divisible? We have to prove 1 or 2 or 3. Do we have, is 17 divisible? No. Is 10 times power 2k? We don't know, because k here, we don't have fixed number for this. Now we go back, we got 99. Is 99 divisible by 11? Yes. Why? Because we can write 99 in this way, which is 9 times 11. That means 99 is divisible by 11. That means the whole number here is divisible by 11, which take us, therefore, number 3 is divisible by 11. We prove 1 divisible, 2, and number 3 is true as well, means divisible by 11. Now we go to last one, which is 22. It's obvious. 22, we can write it 2 times 11, which is 20, means 22 is divisible by 11. That means number 1 is divisible, and number 2, and number 3 plus, and number 4. If you got the first number, and second, and the third, and the fourth are divisible by 11, then the sum of them, first and the second, and which is plus, and the third plus, and the fourth plus, they are all divisible by 11. What that means, go backwards in here, fk plus 1, because all of them numbers in here are all the 1, 2, 3, and 4. It's like made up fk plus 1. That means fk plus 1 is divisible by 11. What we can write in here, each number of fk plus 1 is divisible by 11, means fk is divisible by 11. We can write it each number, of fk plus 1 is divisible by 11. So fk plus 1 is true. Yeah, we're done with this. Then now, this is the main and the core thing when you prove this function is divisible by 11. Then we've proven that fk plus 1 is divisible by 11. Going backwards, just a reminder, first step, what we did, we proven that for n1, which is the basic one, n1 is divisible by 11. It was, I think, 11 times 213, which is divisible by 11. Number 2, we said that for fk, k belongs to n, we assumed that fk is divisible by 11. This is what we said in number 2. And now we've proven that fk plus 1 is divisible by 11. All we have to do now is just go back to number 4 and write the whole answer as simple as this, which is I'm going to show you how to write it, which is that simple and easy, nothing complicated, because this is the main thing what we have to prove, that this function is basically correct and divisible by 11. All we have to write now to keep it simple and easy. Cool. Okay, all we have to write now, what we can say in here, we have shown that the statement is true for n equal k. This is what we did for n equal k. So it's true for n equal k plus 1, and this is all we did. We proven just now. Now we go back to what we said at first. Since we have shown it to be true for n equals 1. This is what we did at first step, which is we said the basic thing, which is n belongs to n natural numbers, n equals 1 is divisible by 11. It must be true for what? For all n belongs to n. And this is the main thing. Your answer has to be written this way. What that means, why do I have to write it this way? Because this is basically, this is all we have been showing and proving in our answer. This will have been answering and showing it. Just we write a little paragraph like this at the end of your answer to show that the answer, your answer, what you have been doing, you answered exactly what you have been doing, not just writing things down. You answered what you have been doing, and you proven that this equation here, which is f, or this function fn equals all this, is divisible by 11 for all n belongs to n, which is natural number. This is a simple and easy and quick example of how to use proof of induction to solve a problem or to prove a problem is true. What you can do here to master this way, how to prove basically equation or function that are true or false, divisible or not, you have to practice and practice and practice and practice, and all the time you have to go back to the basics. Remember, there's 2 steps to prove the proof of induction. It's really important. In meantime, it's going to be easier. The more you do it, the better it gets. This is all for today. Tomorrow we're going to talk about complex numbers. We go slowly. It's going to be really exciting and super easy and straightforward basically topic to talk about. Let me know if you need any help. Again, practice and practice and practice is the key to success in maths. And speak soon.